All right, let's jump straight into this explainer. We're going to unravel the invisible infrastructure of global mobile networks, and more importantly, we're going to solve the absolute mystery of failing roaming connections. You know the drill, right? You land in a new country, you flick off airplane mode, your phone says you have data, but it's completely unusable. We have all been there, frantically toggling airplane mode on and off at baggage claim like it's going to magically fix everything. Today, we're breaking down exactly why that happens, what's really going on behind the scenes, and how telecom operators use some incredibly fascinating diagnostic tools to try and fix it.
It all starts with this incredibly frustrating reality for users, which is basically the silent crime of roaming. As you'll see here, nothing fails dramatically. Web pages just kind of half load, calls half connect, and the data technically exists, but it feels totally unusable. And what happens? Well, the subscriber immediately blames the foreign network, or they just get fed up and buy a local SIM card. Meanwhile, back home, the home operator is left totally in the dark, losing revenue. They can see you stopped using data, sure, but they have absolutely no idea why your experience was so awful.
Now, this directly impacts the commercial bargain of roaming, specifically a system called steering of roaming, or SOR. Operators use this automated tool to basically push you, the roaming subscriber, toward their preferred network partners. Why do they do this? Well, it's all about pricing, volume commitments, or strategic business relationships. It's designed to manage wholesale costs, and honestly, it works perfectly right up until that preferred partner is having a really bad night. When that happens, the whole system just falls apart. The operator then faces a massive dilemma. Do they move you to a backup network? But to make that call, they need total visibility.
Section 1. Intelligence at HQ, or the view from the home network.
To actually figure out if a partner is failing, the home operator basically has to act like a detective sitting at headquarters, and they use a tool called passive analytics to do it. Essentially, this means watching the natural signaling that flows back to the home network across some very specific protocols. Think of these like security checkpoints. You've got Diameter S6a at the HSS. That's basically the bouncer checking your ID to let you onto the LTE network. Then there's MAP at the HLR, which monitors all your old-school legacy voice events. GTP-C on the S8 interface watches to see if the actual data pipe successfully opened up for you to browse the web. And, if the architecture allows for it, it watches IMS paths to check VoLTE setup and actual sound quality. It's called passive because it doesn't generate any new traffic. It's literally just observing the evidence naturally flowing back to give HQ that big picture view.
And the cool part is, passive analytics doesn't just detect that there's an issue, it actively improves the diagnosis. Instead of just seeing a generic failure, it filters out invalid cause codes to find the actual root problem. It separates home side faults from visited side faults so the operator knows exactly who to point the finger at. Plus, it identifies which specific services are affected and extracts location context and serving paths. So it gives you this really broad, incredibly useful overview of what real subscribers are doing across the entire roaming base.
But, and this is a massive but, there is a fundamental blind spot here. A failing eNode B, which is essentially just a local cell tower, let's say at a foreign airport, could stop your connection completely before the home network ever sees a single shred of useful data. Seriously, if the signal dies locally right there on the radio network, absolutely no evidence flows back to headquarters. The passive layer is completely blind to it. It literally has no idea it even happened.
Section 2. Boots on the ground and deploying active testing.
Because of that massive blind spot we just talked about, operators desperately need field agents. This right here perfectly illustrates the technical difference between the two visibility methods. Passive analytics watches the natural traffic returning to the home network, kind of identifying broad trends from afar, right? Active testing, on the other hand, is a totally different beast. It deploys actual physical test SIMs, or probes, out into commercially important places. We're talking airports, transport hubs, central business districts. It literally creates its own traffic to measure exactly what a real phone is experiencing right there on the ground.
Section 3. Solving the case and how both methods combine.
So how do these fundamentally different approaches actually work together to create total network synergy? Let's walk through it. Step 1, passive analytics detects a potential issue or a broad trend all the way from HQ. Step 2, it extracts the location context so we can narrow the scope of the problem. Step 3, those active probes we talked about, they wake up and test the available backup partners at those specific sites. And finally, step 4, this combined approach definitively proves if we're dealing with just an isolated local radio failure, like that one bad airport tower, or a massive, broad network outage. You absolutely have to have both to know the difference.
I absolutely love how the source material sums this up. Passive analytics sees what reaches home, active testing sees what happens on the ground. It just hits the nail on the head, right? These two methods are not alternatives you pick between. You literally must have both working together in tandem to make good, accurate roaming decisions.
Section 4. Decoding the evidence and what roaming KPIs actually tell us.
Okay, let's dive into the evidence itself, starting with data access. What do these metrics actually tell us when we combine our passive and active tools? Well, a subscriber goes through a chronological sequence. First up is the LTE attach gate, like can your device even get onto the network? If that succeeds, we move to the PDN session setup, meaning, okay, you attached, but do you actually get a usable data session? And finally, we evaluate the data experience itself by measuring TCP round trip time, TLS, and those modern quick handshakes. In simple terms, we're measuring those split-second back-and-forth hello delays that genuinely dictate how fast your apps actually load in real life.
Now, voice requires a totally different lens depending on the technology. For Volte, we're measuring if the call can even start in the first place, and we check the MOS score to ensure the active call actually sounds acceptable to a human ear. But what if you drop down to a legacy 3G network? Well, then we're looking at CS registration, like does the visited network even know your phone is physically there? And we look at MAP PRN, which basically checks if the network can actually route an incoming call directly to you. These metrics are crucial because they catch those infuriating silent failures where you miss important calls and have absolutely no idea why.
However, the main thing you need to take away from this is that these KPIs are not magic certainty engines. They do not magically prove that an automated steering decision is 100% correct. Because, look, no home operator has perfect, godlike visibility into a foreign network, and obviously no active test grid has a physical probe at every single corner of the globe. These metrics are simply decision support signals meant to reduce uncertainty. They desperately need the context that you only get by combining the data from HQ with the data from the boots on the ground.
Section 5. The complete picture and making the steering decision.
So, once you have that complete picture, how does an operator actually decide to pull the trigger when they're dealing with a localized versus a broad failure? Well, a credible roaming framework has to ask 3 vital questions before doing anything at all. Step 1, is the problem actually real or is it just a weird anomaly? Step 2, is it broad enough to actually matter at the visited network level? And step 3, is steering of roaming even the right tool to fix it? You have to ask these questions. Otherwise, operators might needlessly move thousands of subscribers to a totally different network just because of one malfunctioning cell tower at the airport. You only steer if the combined data proves it is a broad enough issue to justify it.
We are going to leave you with this final, truly critical thought. The absolute strongest roaming platforms understand the limits of their own data. Because ultimately, every single bad steering decision is paid for twice. You pay for it once in wholesale cost when the operator needlessly moves traffic to a much more expensive partner, and you pay for it again in subscriber trust when the user's connection doesn't even improve after all that. So knowing just how complex this hidden, invisible world really is, can you really afford to navigate it without both active and passive visibility working together? Are you relying on an incomplete picture? Definitely something to think about the next time you land at a new city, take your phone off airplane mode, and wait for it to magically connect to the world.